All right. Welcome to our next JASP tutorial. We're going to focus on the one-way ANOVA. So we've got a data set here from one of our open data sets within JASP. It is a examination of the impact of how many Facebook friends a profile has and the attractiveness of that profile. Excuse me. Let's take a look at our data set a little bit. We've got a participant number associated here. Is this extremely necessary? No, if we're coding in our data by hand, why type another number when our rows tell us that to? But this does tell us to think about it. So as you're looking at it, do we have repeated measures data or do we have between subjects? Let's look at this a little bit deeper and see if you can figure it out. All right, so if we look at friends, you'll notice we have the ordinal set of data, which which is not what it should be. We should have a nominal set of data. That's a bad coding point on there, because this particular data set, if you look at friends, notice it's got values 102, 302, 502, and 702, and 902, and they've each got a label. This is our grouping variable. And so this is showing us that unlike a t-test where we only have two groups, we actually have 5 different groups of participants that took part. Now, we look a little bit further into our data set. We look at our score. Score is a scale variable. It is our score on our attractiveness scale. So we've got multiple groups. And again, remember our rows are one participant. So this one participant has a group and it has an attractiveness score. This is a between subjects data set. So we're looking at to run that one-way ANOVA, which is of course a between subjects test too. So that should have been a trigger. All right, let's go ahead and click on our ANOVA button. We're then going to stay on the classical side of things and go to ANOVA. And you'll notice all of our variables will populate within here. Our friends variable, of course, their grouping variable. And your grouping variable is always considered your factor. So friends is going to go over here to our fixed factors. And their dependent variable is going to go right here into the dependent variable box. And that is our score. You'll also notice that we can actually get descriptive statistics within this, which is kind of cool. We can get some effect sizes, getting our eta squared. Effect size is a great thing to worry about. Looking at our models, we're not really going to change that. This is our standard model, our assumption text. Unless we had some concerns, we wouldn't need to worry about that. Now, of course, one of the problems with an ANOVA, and a one-way ANOVA in particular, is we've got all of these groups. So if we find a significant ANOVA here, we don't have any good understanding of why. Like, why is this happening? So let's take a look at the results are populated over here on the side. Let's resize a little bit. We have our p is less than 0.05, so we have a significant ANOVA. So somewhere in here, we know there's a difference among these groups. Okay, so if we look at our descriptives, we can probably get a little bit of a guess here. So you'll notice that our 102 and our 902 are much more significant in their means, and our 302, 502, and 702 groups are much higher. So those were viewed as more attractive. Now, we can tell that from our means, but that actually doesn't tell us if that difference is significant or not. So what we need to look at is what do we need to run? Now, depending on our experiment setup, we could be running contrasts. So when we talk about contrast testing, contrasts are a priori test where we have planned for this test before the data was ever collected. It's part of hypothesis. It's part, like imagine we were doing a drug trial. It's part of like, we believe this drug will work. We've suggested it's going to be this much more effective, or this drug is going to be more effective than the placebo and our previous equals drug. But this, whether we use contrast really depends upon our a priori testing and our a priori hypotheses. So our before in that standpoint. So it has to be based on our scientific question that's being asked, and hence why it has to be planned. If we were running planned comparisons and our contrasts, you'll notice we have a whole contrast section where it would ask us, we would choose what kind of contrast we wanted to run, and we would be able to look for that. Now, in our data sets case, we don't have planned contrast. In a lot of data sets cases, you're not going to have planned contrast, mostly because we assume that there's a difference, but we're not exactly sure how that difference might play out. So in our case, we won't be running contrast, we'll be running a post hoc test. So we're going to stick to the standard post hoc test, which is the Tukey, and we will move our variable over. So this is our grouping variable, and now we'll be able to see this. All right, so our post hoc tests have already populated here, and let's take a look. So we get our Tukey value. This is our P for our Tukey, and you will notice, so our group 102 is significantly different from group 302, but that's it. That's the only one that is less than 0.05. Group 302 is not different, is significantly different from our 902 group. Our 502 is not significantly different from 702 or 903 or 902, and our 902 and 702 are not significantly different. So what does this mean to our results? Okay, we have a significant ANOVA, and that's going to be important. But our significant ANOVA is being driven, that effect is being driven by the difference between our conditions 102 and 302, and the difference between 302 and 902. That is what our post hoc tests are telling us. So this is how you conduct a one-way ANOVA. This would also be how you would conduct our contrast and our post hoc tests. And that's all for our analysis for today.